In today's video, we're going to be determining if a number is rational or irrational. Now, remember, a rational number, root word ratio, is a number that can be written as a fraction. Okay, and you can write with whole numbers. Okay, and sometimes we're going to look at scenarios where you can write them as a fraction, you can't write them as a fraction, or you could take a look at the decimal and determine whether you can write them as a fraction or not. The key thing with knowing a rational number, it can be written as a fraction. All right, so this number right here is we're asking to determine if this number is rational or irrational, and give a reason for your answer. So this number right here is rational because it has a decimal that terminates. If you have any decimal that ends and doesn't go on forever, it is a rational number. You can write that as a fraction, because you could write it as this. Let me use a pen. You could write it as 84375 over 1, and then how many zeros? 5 zeros. 1, 2, 3, 4, 5. So you could write that as a fraction. Okay. Submit. I don't want the pen anymore. Can I get off the pen? There we go. Submit it. Okay. Let's look at a new one. Square root of 43. Okay. Now, we talked about square roots before. We know what our perfect squares are. So the perfect squares, right, are right here. 43, when I take the square root of that, it's going to be a number in between 6 and 7. And you could also use your calculator to help you. So I'm going to use the Desmos calculator. The square root of 43, right? And there's this long number. It looks like this doesn't fit the whole entire number, but this is a decimal that goes on forever. All right. So any non-perfect square, the square root of a non-perfect square is going to be an irrational number. All right. So it's going to be irrational because it is the square root of a non-perfect square. So anytime you see a square root of a non-perfect square, you're going to get a long decimal that doesn't repeat. Nice. Let's look at the next one. All right, let's take a look here. 2, 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, and so on and so forth. Okay. This one, it is going on forever. So it could be rational, but does it repeat? If it repeats, you would see 2, 1, 2, 1, 2, 1, 2, 1. But you see a pattern in this, but it doesn't repeat. So for the fact that it goes on forever and does not repeat, that means it is irrational. The decimal does not repeat or does not terminate, right? This goes on forever. The ... means it goes on forever and doesn't repeat. There's a pattern, but it doesn't repeat. That's why it's irrational. Let's take a look at another one. All right, square root of 81. Back to our perfect squares list. 81. Square root of 81 is 9. All right, which is a nice whole number answer. That means it is rational. So because of the square root of a perfect square. Let's take a look at more. All right, this one's 7653, 7653, 7653, 7653. So this one repeats and it goes on forever. So it is rational because it is a decimal that repeats. And there we go. We'll do one more. Square root of 49. Okay. Is a 49 a perfect square? Let's take a look. It is. Square root of 49 is 7. So the square root of 49 is rational because it is a perfect square. Okay. So the scenarios: a rational number either the decimal terminates or repeats on forever, or it is the square root of a perfect square. All right. Our irrational number is a number that goes on forever and does not repeat. Okay. Or it is the square root of a non-perfect square. So that's it for today's video. Work through these problems and always remember, if you're solving for X or Y, always give math a try.